Okay, so during this video what we're going to be doing is travelling through our second task for our week 11 lab, which is going to be focusing on our geological geometry. As you can see here, this question is going to deal with a typical skew boreholes question. Now the way that it's, I suppose, asked is giving you the least amount of graphical information possible, just giving you basically instructions how to start off the particular drawing as well as finish it off. So we're just going to start off now by looking at the question, like always. As well as that, I just want to point out here, I've outlined on this question sheet itself that all the measurements have to be halved. The reason that we're halving them is because if you were to draw it out to the scale that I want you to draw it out to, it's a bit too big for an A3 sheet. Now obviously if you're dealing with an A4 sheet, completing this just half the measurements again of what I've basically told you to change them down to, just so that the scale itself can fit on this page. It'll still be the same solution. So to kick things off, I suppose we might as well start reading it. So on a contour map, A and B are two points whose altitudes are at 40 metres and 50 metres respectively. On the map, B is located 80 metres east of A, and a skew borehole at A is, a skew borehole at A is drilled in a southerly direction in plan and has actual inclination of 45 degrees to the horizontal plane. Okay, so we'll start off by drawing our A. So what I'm going to do is, first of all, I'm going to put an XY line and I'm going to move it up towards, I suppose, above the top half of the drawing sheet, just to ensure that I have plenty of space below where I know I'm going to be completing the construction, I suppose, on my dip strike, as well as the thickness that I'm asked to get towards the end of the question here. Now, nearly always you're going to be completing this down in plan, or an auxiliary view off of plan, so you can take it as a given that you want to do your elevation as high up as possible. So I'm just going to say it around here. This is going to be my XY line. Now if that's not large enough, all I can do is just extend it further out. Now I know that A or B, is going to be, according to the question here, it's saying that B basically is located 80 metres east of A. So I know that if I just pick a random point, let's say around, would be a good point for it now. Let's go say here. I know then that if I travel over from A 40, so I have to half all these measurements. So if I go back here, where it says it's located 80 metres east, so I'm just going to change that to 40, half it. I know this is going to be 40 over from A. Now the reason that I know that it's in plan is because in that part of the question where it says on the map, so the map always looking down that plan view, B is located 40 metres east of A. So I know in the plan it's going to be 40 across, like so. Come over here, my 40 millimeters, like that there, and I'm going to call that B, like so. Now it also tells me that A is located at a height of 40 meters altitude, so that's obviously going to my elevation. I can just go up 40 and I know that's where my A is going to stop. So if I go straight up here, I know that A is going to be up here 40, so I'm just going to it's going to be stopped around there, so we'll call that A. Now as you can see here, every one of my lines are going to be fairly dark, just so that you can see what's happening here on the visualizer. For any lines that are not necessarily need to be as dark as I'm putting in here, just ensure that you're keeping nice light construction lines. Now also, what do I know about this? So I know that a skew borehole at A is drilled in a southerly direction in plan, and so it's southerly direction over here. So basically what I have to write above here is my direction, so just to keep that nice and clear so you can see the north, east, south and west drawn out, so if it mentions anything above here that you can figure out fairly quickly what direction it's talking about. So now we're talking about the southerly direction in plan. So if I look at here is the southerly direction in plan and has an altitude inclination of 45 degrees. So I know that's travelling down this direction. So OA is travelling down this direction, so south, and it is at 45 degrees. Now the problem is I don't know where the bottom of A is as it travels down along here in plan. But I do know that's at 45 degrees inclination. So if I go above here to my A, I get my 45 degrees and I take that down A to hit my XY line. Like so. As you can see here, I need to extend my XY line just so it intersects it. Like so. Down the way. Bring it down 45. You can see where it hits here. Then what I can do is bring basically a line across at A like so. You can see this at 45 degrees. Bring that straight down to intersect my line that's parallel to the XY line from A. Where that hits, I can just get my compass extended from A out to that intersecting line and then swing it around. Now, just by sheer luck, you can see there it hits at the very bottom where my line is. That is the bottom of my line A travelling downwards, okay? Now, what I've basically done there was I knew that it was at an inclination of 45 degrees. So basically I knew my line here. So imagine that the peak here is going to be A, and where I'm holding below here is going to be the point that I found. So basically, in elevation here, what you're seeing is your pencil like this. I basically said that if you're looking from the side, you're looking at this. Then I brought this straight down, and then what you're looking at basically is this, like so. As you can see, it was the true length when it was like this above here in elevation. Then down here you can see that how it's started, and then basically you swing it around with your compass like so to find that bottom point below here. Now basically that you have this distance, what you can do now is locate where B is. So you can see A here, and the very bottom of that line travelling through A is down here, and then you can see the same A and the very bottom below here. Now I'm going to find B. So if I go to my question again, a skew borehole at B is drilled in the northwesterly. So this time it's going northwest, okay? So it's travelling up at 45 degrees this direction here. So what I can do is I can get my 45 degrees again, go through my B and extend. Again, I don't know where it stops. In plan and has an inclination of 65 degrees. Okay, so basically I can find my B above in elevation because I know from up the top of the question it's an altitude of 50. So if I travel up 50 here, like so, and I can call that B. I also know that's at an inclination of 65 degrees. I can find that using my protractor. But if you have an adjustable set square, even better. It's a lot quicker to use. I can set it to my 65. So, like so. Just like what I did with A at 45, now I take a 65 like so. Same thing again, you're basically batting that line around to basically find where it stops along here. So as it comes down here at your 65 degrees, what you can do then, so that's your 65 and this is your 45. As you can see here now, basically you can take that down again, and where that hits off your line here parallel to your XY line, like so, you can now bat that around to hit this line or to intersect it, and you find where that line stops, like so. So I'm just going to highlight the section that we need, that section there, that skew borehole, and I'm just going to highlight it here as well so it's nice and clear. Now you can also find the base of this by bringing that up and bringing that straight to B like so. So now you have your two skew boreholes. one straight down here, traveling your southerly direction, as you can see below here, and then you can see your skew hole here, which is in your northwesterly direction here, and also above here in elevation. Now we could take the last bit of information given in the question itself, was basically to ask where the top and the bottom of the stratum is at the different altitudes. Now the important thing here is, remember, you're dealing with altitudes, so we're not going to be measuring for our 40 and our 22.5. We're not going to be measuring up along the line like so. We're going to be going straight up. Okay, that's important to remember because you're dealing with an altitude, not with how far along the skewer borehole you hit it. It's the actual altitude itself. So if we go for A, so if we look here, for A it's at 32.5 and 12.5, so 2.5 and 12.5. Okay, so I'm going to call this AT for the top of the stratum, and AB for the bottom of the stratum. Then for B, same thing again. It's going to be 40 and 22.5 according to the question. So if you go 40 like so, 22.5 like so, I'm going to call this BT for top of the stratum again, and this BB for bottom of the stratum at B. Now you can join your line, so AB goes to BB. Like so. Same thing over here. AT to BT. Like so. Now what we have to do is we have to locate these two lines below in plan as well. Now the reason that I chose this particular question is because how the borehole basically at A is travelling in a southerly direction. It's a bit tougher to find these two heights here, especially how you're not dealing with a true length that you're looking at here. But remember, we are dealing with a true length when we drew our line here at 45 degrees. So if we actually take them across to hit that, just to find them where they'd be along our true length line, and we bring them down and rotate them, we can locate them basically in our plan, like so. Now ensure you label them right. So this is AB, and this is AT. Now it's very easy to locate them for our skew hole going through B. It's going to be straight down like so. So this is going to be B here, and this is going to be BT. Now I can tell straight away that these lines are going to be basically travelling through each other like that. Now this is not always the case, and it doesn't change anything. The construction will all be the same completing it. Sometimes they go through each other like we see here, so AB goes to BB, and sometimes they don't. Now that's fine. Now what you want to do is basically find your strike, and to find your strike there's a bit of construction to complete, so I'll just show you now. And there's a few ways of completing this, but if you follow the same steps it'll work out the same for the angle that basically the strike travels off at. So if I basically go here, so if I take my line AT to BT here, and I take that parallel from BB, parallel line, like so. So this line is going to be parallel with this line here, which I'm going to indicate with an arrow. Also, you take a level line from AB across, which is already here, and we're at an intersect, which is here. Just call that point O. Okay. Now what you can do is drop that line straight down like so. Then repeat basically what you've completed above here below. So you take your line ATBT, so where's ATBT is here, and you're going to take a parallel line again from BB, and this will travel through that line you dropped here, and you can call that O. And as you can see, O, do you remember how we took a level line from AB across? Now you're going to use your O and draw a line through AB. So you can see AB here, and travel through it and extend, like so. Now what you found there is you found your strike. Now if you also do basically a perpendicular line to that, and you're basically constructing here an auxiliary view, call this line your X1, Y1 line. Now all your lines that are going to travel through this will be perpendicular to your X1, Y1, or parallel with this line here, your strike, and you're going to take your distances above here in air elevation and knock them off. Now what should happen is these two lines should appear parallel when you've completed this construction. Now just make sure that's correct. We'll do that. So take all my lines and my two lines across. So I have my AB across. Now I need my AT across. Now the only reason these won't be parallel is if you've gone somewhere wrong in your construction, or if you have gone a small bit off with a small bit of inaccuracy. Now, like I was saying before, take your distances from elevation. Where's my compass gone? So for AB, go to AB here. Get that distance. Mark it off. Call that AB. AT then. Like so. BB. And then BT. Now it's looking good already. It's looking like they should be parallel. I'll make sure that BT. That's BT. Now, just to ensure that they're parallel, what I'm going to do is I'm going to draw a line between one of them. So let's say AT to BT. Then what I'm going to do is get my sliding set squares and ensure that they're parallel. Now, if they're not parallel, there must have been a small bit of inaccuracy. And perfect. Now, if you don't get them perfectly parallel like I have there, just a small bit of inaccuracy somewhere back along, just be careful of that. If it's a tiny bit off, I wouldn't be too worried. If it is a full degree off or 2 degrees off, it's starting to look a small bit sketchy. I just ensure that all your measurements are correct. Go back and check. Now also what we can get from this is we can extend our X1, Y1 line like so. Extend either one of these lines. Let's get a closer one. Where that basically touches below here, you can basically get your dip. So this angle here that we created is your dip. And then your thickness is basically the distance between these two lines. So if you do a perpendicular line to either one of them, so draw a line, there on it, that's your thickness. Now once you have that complete, you're finished. Now for, like I was saying before, not always these will be crossing below in plan. It's always the same construction. You can see how I found O here. Now you didn't have to do it. You could have done a parallel line from AB and BB. just as easily. It doesn't have to be this particular rope, but your strike will always be off in the same direction, like you can see here. But after that, you're complete. Like I was saying, a few other things that are important here is just remember that you have to half all your measurements if you're doing A3, and then what I do if I was doing A4, I just quarter them. It's handy enough just to draw out your north, east, south and west as well, so when you're looking at a question you can find out quickly which direction you're dealing with, and I suppose stop yourself from making mistakes that could happen. Past that, it's a nice quick question. As long as you understand what's happening, it's a good one to do within a test, I find always, because you can get it done very, very quick, and as well as that, it's pretty simple.